Welcome back to our grade 11 maths lessons. I am Miss Awinu, one of your maths teachers. In our last lesson, we were looking at geometry, okay, and the basic elements, which are points, lines, and distance. In today's lesson, we are going to look at vectors, okay, vectors. A very nice word used in maths, vectors. All right, now what are vectors? Very simply, vectors are lines. They are lines. Any which way you draw a line, let's say this is our line. This is a vector because vectors will need to have the length, all right, measurement, which sometimes is referred to as magnitude, okay, and direction, okay, direction. So a vector is simply a line that has length and direction, okay, or magnitude and direction, okay. So let's see, this is a vector because I have a length from this endpoint to this endpoint, and the arrow head, all right, indicates a direction that this line is moving. Okay, so that's simply what a vector is, a line that has length and direction. Okay, now, remember in maths, we always use numbers, and we can actually measure these vectors, all right? We measure the vectors with the help of our Cartesian plane. So we're going to draw a Cartesian plane. Now, this vector can be at any point on our Cartesian plane, okay? For this example, let's say there is a point here, and I'm going to say this is Boroko, and I'm here at point A. I want to get to Hohola, all right? And let's say Hohola will be at this point, okay? And we'll call this point B, all right? Now, for any vector, it must have a name, okay? Now, we go back to this line here. Let's say this is line AB. So this vector will be represented as, and this should be familiar to you, we call this a line segment in our last lesson, okay? So if you have lines and you need to find length and direction, then this is a vector now. And we use this to represent vector AB, all right? So I am going to put vector AB already here on our Cartesian plane, and I am at point A, and Hohola is point B. I want to get to Hohola. Now, assuming I'm traveling in a straight line, they are not any turns. I'm not on a bus traveling from 4 miles. So anyway, we are moving in a straight line from Boroko to Hohola. How do I find the direction I need to go to get to Hohola? Okay, now, using your Cartesian plane, we measure direction because it is the change. All right, let's write it here. The change in the x value and the change in the y value. Okay, x and y value. All right. The change in x value and the change in y value. Where are those changes happening? The direction across your x-axis and the direction up or down the y-axis, okay? So if I were to give the direction of this vector and how I need to travel or where, the direction, I will give this vector as, okay, let me write it up here, vector AB will be given as coordinates or x and y value, okay? So x value here, let's draw from point B down to the x-axis so we can see where it is at 2. So I'm going to write 2, all right? And then the distance up would be to the point here, which is 3. So this vector AB is in the direction of 2, 3. Remember, if I were to ask you to give me the direction, you can't simply write it as an arrow. It needs to be as coordinates. Remember, coordinates give location, and in this instance, it's the direction I have to travel. Okay? Now, if I give you a vector with a measurement, you should be able to draw it on a Cartesian plane to see the direction in which this vector is going. Okay? So let's say vector AD is in the direction of -1, +4. Okay? Now this vector goes across to -1 here, and then goes 4 units up to +4. Okay? So let's just draw where the point will be first. Okay, here. And the vector will be from this point down to that point there. So this is vector AD, all right? Starting at the origin. Now, we found the direction in which I have to go to get to Hohola, but how much distance do I need to cover to get to B? And that is represented by the length of our line. Okay, the length of our line. Okay, if I were to write this, let's see, AB. Now watch, if I put 2 strokes here, and AB, that tells me that I have to find the distance or the length of the vector. Okay, so you can already tell from our diagram we've drawn a right angle triangle using the vector AB, the distance along and the distance up. Okay, so that should already tell you what method we are going to use to find the vector AB. Okay, now to find the length of vector AB, you can already tell from the diagram on the Cartesian plane, we've formed a right angle triangle, okay? And that should already tell you that we are going to use Pythagoras theory to find, all right, the length of AB, or the length of the vector, okay? So Pythagoras theorem, let's look at AB, vector AB, okay? And we are going to square this. Square of AB is the hypotenuse plus the sum of the 2 short sides here, which is 2 squared plus 3 squared, okay? 2 squared is 4 plus 9, okay, will give us vector AB squared. Okay, this is 13. Remember, we have to remove this square sign across to that side. So it becomes root of, all right? So length of vector AB is the square root of 13. Okay, vector AB is the square of 13. That's the length of AB. So, very easy. It doesn't mean vector new term and then you're thinking it's something very different. It isn't. We've learned about Pythagoras already. We've learned how to use the Cartesian plane already. It's just applying what we've already learned. Okay? So in our next lesson, we are still going to talk about the length of the vector. This time, we are going to use trigonometry. All right, if you've forgotten how to use that, go back to our previous lessons and find trigonometry, review before we cover the next lesson. I hope you can join me then.